9.5 is full of properties of logarithms. So this first slide is if you want to write down all the words all together, go ahead and do that. The second slide is for writing down all the examples. So I technically did the second slide and the first slide, but however you need to do it, you have two slides where you can put every single theorem down that you need for this section. So the first one is a logarithm of 1, and this is log base of any base of 1 is 0 because any base to an exponent of 0 is 1. Logarithm of the base log of base b of b is 1. That's because any base to the first power is that original base. Logarithm of the power of the base, so log base b of b to the n equals n, because b to the n equals, imagine that, b to the n. Logarithm of product, these two, the next two, actually the next three are the more different ones you haven't seen or wouldn't think would work, but they do work. There are proofs for those throughout. Logarithm of product, that proof is on page 588. One of the homework questions asks for the quotient one, and then the power, there is another proof in there as well. Because we're not dealing with proofs on the quiz test thing at the end of chapter 9, and they're more interesting if you read them. I'm not going to make you write a proof. If you're going to do higher math in college, this is a great time to look at it and see if you can read it using the math words and the expressions they use. So for homework, we're skipping number 6, 7, 18, and 21. On 23, just as an instruction thing, they want you to do more detail, but just reference the best theorem that you can see for that, each for the parts. Just reference the best theorem out of this list. They won't all be perfect, but just pick one that's close, and that'll be still good practice of applying the theorem to the situation and why they used it. But again, we're skipping 6, 7, 18, and 21. I do also want to mention, if you like this as a big flashcard, the next section, so 9.6, is going to go over change of base. So this was before calculators could change your base for you, and you had to deal with natural logs only or base 10 only. But if I have a log of some base of some argument, I can actually write that as a fraction using the same base, but moving these two values into the argument's position. This was really helpful with base 10 typically. So if I, for example, had log base 5 of 6, I can write that as log 6 over log 5. And if you have only a table or a chart that has the common logs or the base 10 logs of 6 and 5, you can figure out this fraction. But if you don't have a table for base 5 logs, then you're out of luck. So this is for next section, but if you want to write it on the same piece of paper with everything else, I would highly suggest that.